Now we go to B4. Now B4 is a question that is very similar to a question that showed up on our first midterm. We have a function, in this case, sech of x, which is our hyperbolic secant function. And we are wanting to consider this function and turn it into, restrict it in some way to create a invertible function. So consider the function sech x, restrict the domain such that the function becomes 1 to 1, and the codomains such that the function is onto the graph of and it should be sech of x is given below. Express the domain and range using interval notation. So if we go here, if I look at this function, I want the domain and range. So here I include this point. So I want to circle here. I want to go down, continue off to infinity. We like positives instead of negatives. So the domain being from including 0 to infinity is lovely. This entire thing, we are past the vertical line or horizontal line test, so we're 1 for 1. This means that my range would be not including 0 up to and including 1, because here I am here, but I never get to 0. Okay. So that is my domain and my range. I've got my interval notation for my domain and range. Now using A, so using this expression, determine the domain and range of arcsin of x. Express the domain and range using set builder notation. So the domain is the range of the original function, but set builder, it's the set of x in R such that 0 is less than x, which is less than or equal to 1. And the range is the set y in R, and we'll 2 little lines to make it the real numbers, such that y is greater than or equal to 0. And that is the range and domain of the inverse function. Because the range of the original function becomes the domain of the inverse, the domain of the original becomes the range of the inverse. Now we need to show that arcsin is ln 1 over x plus the root of 1 over x squared minus 1. And from here we start with x equals 2 over e to the minus y plus e to the y. From here, I'm going to multiply that up to get x e to the minus y plus e to the y equals 2. I can do this because this is always positive. I'm going to multiply both sides by e to the y, which again I can do because both is positive. So I get x 1 plus e to the 2y equals 2e to the y. So now getting this by itself, I get e to the 2y minus 2 over x e to the y plus 1 equals 0. Now this here is the same as e to the y squared minus 2 over x e to the y plus 1 equals 0. Now, using the quadratic formula, e to the y equals 2 over x. This equals 2 over x plus or minus the square root of 2 over x squared minus 4 all over 2. A, and A is 1, so all over 2. So this e to the y equals 1 over x plus or minus the square root of 4 1 over x squared minus 1 all over 2. And now this 2 I can bring inside. So it's 1 over x plus or minus the square root of 4 over 4, 1 over x squared minus 1. which equals 1 over x plus or minus the square root of 1 over x squared minus 1. Now, because we took the positive branch of our function, my output there, that we know the range is going to be positive. But with that range being positive, we're looking at it and go, okay, which one of these branches am I going to pick? And if we look at our function, because we took this positive branch here, that means that my output, if I rotate it, is going to be the positive one from the root. Okay, so it means, so as we have a range of 0 to infinity, we must take the positive root. So because we have to take that positive root, we have to go off to infinity. We have to take that positive root. This means that e to the y, thus e to the y equals 1 over x plus root 1 minus x squared minus 1. So y equals ln of 1 over x plus root 1 over x squared minus 1. We have our solution. Now, B5. B5 is very similar to all of our other ones that are like this. We have our function, f of x equaling sine of x, f inverse of x equals arcsin of x, f prime of x equals cos of x, using the inverse function theorem. The derivative of arcsin of x equals 1 over cos of arcsin of x. The question is, what is cos of arcsin of x? Well, if sine x equals theta, then arcsin of x, arcsin of theta equals x over 1. So if we draw our cast rule, we get two triangles. Remember, arcsin's range is minus pi by 2 to pi by 2. Our opposite is x. Hypotenuse is 1. This is where x is greater than or equal to 0. This here is where x is less than 0. And this last piece here is the square root of x squared minus 1. Now you'll notice for both the positive x and negative x, I have this same root. So cos of theta is going to equal root x squared minus 1 all over 1. And this equals cos of arcsine x. So this equals 1 over root x squared minus 1. And here, because of the cast rule, because of these domain constraints that we've incorporated, we've dealt with the argument for why it's the positive root. That's incorporated in this picture. Okay.